Welcome back to our series on probability theory. I'm Mark Ledbetter, and this is a video to go over the solutions to in-class exercise number 2, which covered chapter 1 in some brief detail. So we have the problem where we have 10 red and 10 white balls in a container. And we select balls from the container at random, one at a time. We want to find the probability that the fourth red ball is the fifth ball selected. And we're going to do this first with replacement. So the easiest way to do this, I think, is to draw out 5 places for the first ball, the second one, the third, the fourth, and the fifth. Now, I'm going to say let capital R equal red ball selected, and capital W equals white ball selected. So it says that the fifth ball that we select has to be a red. So that is given. And if it's and we're saying that there are 4 red balls out of 5. This tells us that out of the first 4, there has to be 3 red balls selected. Now, the probability of a red ball is 10 over 20, or 1/2. And the probability of a white ball is 1/2. And we're replacing the ball into the container after we select it, so these probabilities will not change. So let's say that we select a red ball, then another red ball, then another red ball, and then the last one has to be white. So there's going to be 3 red and 1 white in the first 4 balls selected. There has to be, in order for the 4th red ball to occur when we draw the 5th or make the 5th selection. And the probability of this occurring is that we have 1/2 times 1/2 times 1/2, 1, 2, 3, 4, 1/2, and then 5, 1/2. So this particular order is 1/2 to the 5th. So 2, 4, 8, 16, 32. So this is 1 over 32. But the ways that we can have 3 red and 1 white in the first 4, we don't care about the order, we just care about unique. We don't care about which red ball is first, we don't care about the individual balls. We just care about a distinguishable permutation. So any red ball first is the same for our cases. Okay, so that means there are 4, in the first 4 balls drawn, there are 4 total balls, and 3 of them are red. And so this is 4. Anytime we have n, choose n minus 1, that is going to be n, and in this case it's 4. So the probability that the 4th red ball occurs on the 5th selection is 4 times 1 over 32, or 4 over 32, or 1/8. Now, we're going to do this without replacement. It's the same principle. I'm going to say that the first one is red, the second one is red, the third one is red, the fourth one is white, and it doesn't matter as long as there's 3 red and 1 white in the first 4, and then the 5th one has to be red. So So this will be the first, second, third, fourth, and fifth. And so the probability of getting a red ball on the first draw is 10 out of 20. You'll notice that I use the full numbers when we have without replacement. The reason for that is I have now drawn one ball out of the one red ball, and I have not replaced it. So I now have 9 red balls left, and I only have 19 total balls. And then I've drawn another red ball. So for the third draw, I only have 8 red balls left out of a total of 18. And then white, there's still 10 of them, but only out of 17 for the fourth. And then for the fifth ball, which is supposed to be red, there's only 7 red out of 16. And so when I multiply this, so 10, 9, 8, 10, 7, that's going to give me 50,400. And in the denominator, I'm going to get 1,860,480. And again, there's only one way we can choose the fifth ball. It has to be red. But there are 4 choose 3 ways to select the first 4 balls where we have 3 red. And so again, that is 4. So the probability that of fifth ball being fourth red is equal to 4 times 50,400 over 1,860,480. And this multiplies out to be 201,600 on the top, and we keep 1,860,480 on the bottom. That is a great answer as far as I'm concerned. If you put this to a decimal, it's 0.108359, etc. Okay? So that's the first problem. Now, the second problem, we're given a table. And it's about sheets of paper, and we have tear strength and we have burst strength that are tested on each of these sheets of paper. And there are 3 levels, low, medium, and high. And for tear strength, that's going to be B1, B2, B3. For burst strengths, it's going to be A1, A2, A3. We're going to randomly select one piece of paper. We want to know what's the probability that it has the following characteristics. So for A3, the probability of A3, we simply total these up, and we'll total everything. I'll put total here, I'll put total over here, and we will total up everything. And here we have 20 or 31. Here we have 42. Here we have 27. And if you add those together, you should get 100. You better get 100. And then for the first row, that's 29, and then 40, and then 31. And again, those add up to 100. So the probability of A3 is simply 27 over 100. No work is required for this one, it's obvious. Number 2, the probability of A1 and B2. Well, now we have A1 here, and we have B2 here, and where they intersect is 12. So this is just simply going to be 12 over 100. Finally, C, we want the probability of A2 given B2. We could use the conditional probability formula, but we have a table. And so we're only interested in B2. So I'm going to reduce my sample space to just the case where B2 has occurred. And I want to know A2 given B2, that's simply going to be 20 over 40. And that is a fine answer for me. Of course, this is equal to a half as well. Okay, so that's it for problem number 2. Now, finally, for problem number 3, we're given these different probabilities, and we're asked to determine if A1, A2, and A3 are, first, pairwise independent. So, these are pairwise independent if 1, the probability of A1 and A2 is equal to the probability of, I'll say which is equal to, A1 and A2 is equal to 0.0288, and if they equal the probability of A times 1 times the probability of A2, which is equal to 0.12 times 0.24, which is in fact 0.0288. Secondly, the probability that A2 and A3, which is equal to 0.0864, if that is equal to the probability of A2 times the probability of A3, which would be 0.24 times 0.36, and that is in fact 0.0864, so that's true. And finally, the probability of A1 and A3 is equal to 0.0432. If this is equal to the probability of A1 times the probability of A3, which is 0.12 times 0.36, which is in fact, and I wrote this, so this is 0.0432. So A1, A2, if all of these are true. Hence, A1, A2, A3 are pairwise independent. Now, we want to check if they are mutually independent. This requires, so if A1, A2, A3 are both pairwise independent, or I shouldn't say both, are pairwise independent, and if the probability of A1 and A2 and A3, which is equal to 0.010368, is equal to the probability of A1, probability of A2 times the probability of A3, which is equal to 0.12 times 0.24 times 0.36, which is in fact 0.010368. Hence, because A1, A2, A3 are pairwise independent from part A, and probability of A1, A2, and A3 equals the product of probability of A1, probability of A2, probability of A3, they are mutually independent as well. Okay, and that is it for this in-class exercise. I hope this explains the solutions well. As always, if you have questions, feel free to ask me. Always happy to help you with the course content. So please take care of yourself, stay safe, because we want to see you next time.